Hello everyone, I am Nandini MK, 4th sem studying in SVC College of Bangalore. Today topic is Fundamental Principles of Counting in a Discrete Mathematics Structure. Introduction of a Discrete Mathematics. In a discrete mathematics, counting is a fundamental concept used to solve problems. Counting principles helps in determining the number of ways event can occur. Understanding basic counting principles is essential for solving a combinational problems. The next is multiplication principle. The multiplication principle states that if there are m ways to do one thing, ways to n another, there are m into n ways to do both. This principle is based on the idea of independent events. It is a fundamental concept used in counting arrangements and combinations. The next is factorial notation. Factorial notation is denoted by the symbol and is used to represent the product of all positive integers up to a given number. This is the example of a factorial notation. Factorial notation is commonly used in counting permutations and arguments. Permutations. Permutations are arguments of an object in a specific order. The number of permutation of n distinct objectives is given by n factorial. Permutations are used when the order of object matters. The another one is combinations. Combinations are selection of an object without considering the order. The number of combinations of n objects taken R at a time is denoted by n choose R. Combinations are used when the order of object does not matter. The next is binomial coefficients. Binomial coefficients represent the number of ways to choose R elements from a set of n elements. Binomial coefficients are denoted by a n choose R. Binomial efficients play a crucial role in a binomial expansion and probability theory. Now we have to know a sum principle. The sum principle states that if there are m ways to do one task and one ways to do another task, the total number of ways to do either task is m plus n. The sum principle is used to count a mutual exclusive events. It is the fundamental concept in counting the total number of outcomes in a given scenario. Inclusion-exclusion principle. The inclusion-exclusion principle is a counting technique used to calculate the number of elements in the union of multiple sets. If the account for the overlapping elements between the sets to avoid a double counting. The principle is essential in solving complex counting a problem involving multiple sets. Pigeonhole principle. The pigeonhole principle states that if n items are placed into m containers where n is greater than m, then at least one container must contain more than one item. This principle is used to prove the existence of repetitions or patterns in a given scenario. The pigeonhole principle is a powerful tool in a combinational mathematics. Principle of a bijection. The principle of bijection states that two sets have the same cardinality if there exists a bijective function between them. Bijection establishes a one-to-one corresponds between elements of two sets. This principle is used to show that two sets have an equal number of elements. The next is Burnside's lemma. Burnside's lemma is a counting technique used in combinational mathematics and group theories. It provides a formula for counting the number of orbits of a group action on a set. Burnside's lemma is useful in solving problems involving symmetry and equivalence relations. The another one is principle of a complement. The principle of a complement states that the number of ways an event can happen is equal to the total number of possible outcomes minus the number of ways the event cannot happen. This principle is applied to find the number of favorable outcomes by subtracting the unfavorable outcomes from the total outcomes. The principle of a complement is helpful in solving probability and counting problems. Principle of a division. The principle of a division is used to distribute objects into groups or categories. It involves dividing a set of objects into non-overlapping groups. The principle of a division is applied in counting problems related to partitioning and distribution. Principle of a recurrence. The principle of recurrence is also known as the principle of a mathematical induction. Is a proof technique used to establish statement for all natural numbers. It is based on the idea of proving a base case and then showing that if the statement holds for certain number, it also holds for the next number. The principle of recurrence is fundamental is proving the properties of recursively defined sequence and structures. The next is principle of inclusion and exclusion. The principle of inclusion and exclusion is a counting technique used to calculate the number of elements in the union of multiple sets. It involves a systematical including and excluding elements for sets to avoid double counting. The principle of inclusion and exclusion is essential in solving complex counting problems involving multiple sets. The next is principle of a symmetry. The principle of a symmetry states that if there is a symmetry in a problem or argument, the number of distinct cases is reduced. Symmetry can simplify counting problems by reducing the number of a distinct configuration to consider. The principle of a symmetry is often used in a combinational problems involving a geometric shapes and arguments. The another one is principle of a subtraction. The principle of a subtraction is used to find the number of a ways an event can occur by subtracting the ways it cannot occur from the total possible outcomes. It simplifies counting problems by eliminating cases that do not meet the desired certain. The principle of a subtraction is commonly used in counting problems involving a restriction and condition. The principle of a duality states that for every combinational rules or theorem there is a corresponding dual rule obtained by interchanging certain elements. Duality allows for the conversion of statements about one type of object or operations into statements about another type. The principle of a duality is useful in simplifying proofs and deriving a new result in combinators. Principle of equivalence. The principle of equivalence states that two mathematical objects or structures are equivalent if they have the same properties or satisfy the same conditions. Equivalence relations establish a relationship between objects based on a set of the criteria. The principle of equivalence is used to classify objects into equivalent classes and simplify counting problems. Conclusion of the fundamental principle. The fundamental principle of counting in discrete mathematics structures are essential for solving combinational problems. Understanding counting principles such as a multiplication, factorial, notation, permutation, combinations, and various counting techniques is crucial in discrete mathematics. By applying this principle effectively, mathematicians and researchers can analyze, solve, and optimize a wide range of counting problems in various fields. Thank you.